We have an SMO type problem here that I think is kind of a challenging problem. I think it's actually a junior problem from Singapore Mathematic Olympiad some year. And I'm sorry, I've lost track of what my source was, but I'm almost certain it was an SMO problem. Now, the thing that makes this work is we have a fourth degree polynomial with a missing cubic term, but that means that we have a 0x cubed term right here. Now, again, we're given that we have four roots, not necessarily distinct. And so what I did right here is I did an expansion. Y'all apologize, I can't make this type, the print any larger because it just won't fit on the screen. But what we get right here is when we expand this out, and it is very time consuming and tedious just to expand this out. Right here we can see we do have a cubic term that involves the sum of all the zeros as the coefficient. So what we can conclude right here is that, and this turns out to be vital, we can conclude that x sub 1 plus x sub 2 plus x sub 3 plus x sub 4 has to equal to 0. Okay, and again, folks, that's this problem is hard enough, I think. But if it weren't for the fact that we had a 0x cubed term, we wouldn't be able to equate the coefficient here, which is the sum of the zeros, to 0. So that turns out to be quite important. Okay, now we are given that the product of two of the zeros is 45. Okay, we're given that the product of two of the zeros is 45, and we're supposed to find this value a. Now what I've done here, folks, the a is the coefficient of x squared. And I made this green just so your eyes won't get tired and I won't have to talk so much. But what we have right here is a is equal to all of this. And we are also given that x sub 1 times x sub 2 is equal to 45. So you see on this very next line, you can see that's where the 45 comes from. Okay, that's where the 45 comes from. And also this statement right here, the 2610, that's the product of all the roots, right? So the 2610 that you see right here is actually equal to this because these are just constants. The minus signs cancel out, and so we get 2610 is equal to the product of all the roots. But notice, along with this given information, that implies that x sub 3 times x sub 4 is 58. Again, 45 times 58 gives you the 2610 you see. All right, so you see we've kind of used two pieces of the result now. Now the rest of this, we're just going to kind of bump along here. So we now know we can write a like this, okay? And so what we can do right here is, this part was kind of hard for me. You can factor out x sub 1 from the first two terms. Okay, you can factor out x sub 2 from the second two terms, and we get kind of a factoring by grouping here, okay? And so we have a down to this form, okay? Now, what turns out to be useful, in that the last piece that we haven't used is all the triples, all the products of the triples of the roots is actually, the sum of that is the coefficient of x with the minus sign, okay? And so that explains why I wrote down minus 182 here. You can see that plus 182 is what's written here, but we had to write down minus 182 right here because of this minus sign. And y'all, by the way, this is all called Vietas. You know, I'm just doing it by hand rather than trusting the Vietas formulas. Okay, don't trust Italians, right? Now, okay, how did this happen? Well, you see, we know that x sub 1 times x sub 2, again, x sub 1 times x sub 2 is 45, and we see x sub 1 times x sub 2 twice here, right? And again, folks, that was a given in the problem, all right? And also we deduced that 58 was x sub 3 times x sub 4. And so you can see how the algebra follows right here, okay? So we get this statement right here, all right? Now we are making progress here. Now here's the very last step that kind of stumped me just a little bit, but let's go all the way back to the beginning. Remember, we know that, let's see, do I have it all on the screen? Yes, I do, okay. we deduced very early in this problem that the sum of the zeros has to be equal to 0, right? And so you can see what happened right here. This is true simply because from this statement right here, I'll come up here. This implies that x sub 3 plus x sub 4 is equal to the additive inverse of x sub 1 plus x sub 2. That's what makes it fly. Okay, so this is equal to minus the quantity x sub 1 plus x sub 2. Okay, so that little observation at the very beginning, which is crucial, comes right back here. That's how we could replace x sub 3, x sub 4 with minus x sub 1, x sub 2. It all follows from right here, folks. Hope that makes sense, okay? Now, so what we get is this. We're close to being done, folks, because 58 minus 45 is 13, right? Okay, now what does this mean? Okay, if you divide, 182 happens to be divisible by 13. 13 times 14 is 182. So this implies that negative 14 has to equal to x sub 1 plus. Now this is major progress, right? X sub 1 plus x sub 2. And folks, you see why that's the coup de grace. Because right here, that's going to turn this. You see, we know that x sub 1 plus x sub 2 is additive inverses with x sub 3 plus x sub 4. And so what we get right here, folks, is this 45 plus minus 14. And just to avoid any ambiguity, I'll envelop this in parentheses. Well, actually, that's wrong. Okay, let me erase that. Sorry. Okay, so this would be minus 14 squared, right, folks? Because what we have here, this is minus 14 and this is 14, right? So then we get the plus 58. I believe this is equal to, if we do the positive numbers, this is what, 58 and 45 is 103, right? 58 plus 45 is 103, 103. So we get 103 minus 196, which is 14 squared. Okay. And so we have actually solved this problem, folks. It's kind of fascinating, and I love this stuff. Minus 93 is the solution. And that is the answer to our problem, folks. A is equal to minus 93. Again, folks, this is very much like an IMO problem, and I think it was a junior problem all the way back in 2004. Not IMO, SMO, Singapore Mathematical Olympiad. Okay, minus 93. And that's all. Let me know if you see an easier way to do this, folks. But what they tell the kids to do who are in that competition is to memorize this thing called Vietas. And it's terrible to memorize. I think you don't have any choice sometimes but to memorize. But this is why Vietas actually holds. And again, this part right here is very time consuming. It takes at least 15 minutes to do it by hand. And it's very, very error prone. But I double and triple checked it and I think I got it right. So this is why Vietas works. Thank you for viewing.